right. Welcome to Data Science Club number 18. Today we're going to talk about sentiment analysis using Python and natural language processing. So sentiment analysis, for those of you who haven't thought about this at all before, is basically how can we use a computer to tell us whether or not a block of text overall has a certain feeling. So in this data set, I think we're going to be looking at movie reviews, and so we're seeing, is this a positive movie review? Did somebody really like this movie? Or on the flip side, did they really not like it? And we're going to do that just based on the text, and we're not going to be using some kind of star rating or anything like that. So that's kind of what we're getting into today, and so it should be fun, and let's see what we can do. All right, so we're going to be using this tutorial here. It's in the comments below, but the sentiment analysis with Python part 1. If you want to skip straight to just doing code stuff and not doing copy pasting stuff like what we're doing, you can click on this GitHub repository, and he's got all his code right there. We're going to do it a little bit more step by step and just see what we can do. All right, so first things first, we need to download these movie reviews, and we want to get them on Chiha, because we're going to be using the UAB high performance computing platform. So what we're going to do is we're going to copy the link address here, and then we're going to do a little bit of command line stuff. So we're going to go to Chiha shell access, and again, this is if you go to rc.uab.edu and you have a UAB Chiha account, you can do this. If you don't, you can open up a terminal on your own machine. If you've installed Anaconda, you can open up a terminal through Anaconda, and you can download that way, or you could just click and download it to your machine directly. Since we're downloading it to the cluster, we've got to type things in on here.
And if you guys are at UAB but don't have a Chiha account, send us a request and we'll create an account for you.
Yeah. And again, if you have trouble downloading this stuff, let us know as well. So we're going to go to our data directory, because that's where we should keep all of our data. All right. And then I believe if you've been following along, you have a rc-dsc folder. So we'll go in there and we'll make a directory, and we'll just call it sentiment. Okay. So make dir is that command, mkdir, and so then we're going to go into that folder. All right, and we're going to use a command. Which one would you recommend for downloading a file based on the link?
wget should be.
Wget?
Yeah,
okay.
Wget should be a good command.
So it's as easy to spell as it sounds, wget, and then we're going to paste the link to that that database here, and it should, if we do this,
it would start downloading.
Yeah, so now it started downloading.
I mean, there are some other commands that you can use on a Linux terminal or a Mac terminal, like curl, that also gives you the functionality of pulling down the data. But I think wget is the more universally used command. So.
All right, and if you have any trouble with that step, feel free to send us a message or come into office hours. We're happy to help out. All right, so now we're going to go back to the tutorial, because he goes through a couple of data preparation steps. So first thing, okay, so yeah, he says double clicking it should be sufficient to unpack it, but we're actually not doing this on our desktop, so we're not going to double click it. Do we need this dash in there?
Yeah, we do, but we can even just use star xcvf rather than.
Oh, okay.
I don't know
All
what I was
right.
trying to.
So Ravi's gonna tell us a better command. So we're gonna go tar
xz
z
vf
vf
and the name of that.
and then the name. Okay.
Yeah.
All right. So that will unpack this, so you can see it's spinning quite a bit. So each one of these text files is a separate movie review, and you can see that, well, it might be going too fast, but basically there's positive and there's negative movie reviews. I don't know what unsup is. Maybe that's for an unsupervised training potential.
Yeah, maybe. I mean, so if you guys are following along and if you read the Medium article a little forward, it's basically they have 50,000 movie reviews, and they have split it like if the rating was less than 4 star, then that goes into the negative section, and or if it was greater than 7, I believe, then it goes into the positive section.
Okay.
5, 6 they just discarded.
Okay.
That's like neutral. You know.
Yeah.
So their opinion doesn't count.
Yes. All right. So we've downloaded it. We've unpacked it. And now what we're going to do here is we're going to go into that directory, and we're going to make a new directory called movie data. So if we just copy and paste that line. So cd is change directory, and then we're also running this command for making this other directory. Okay. So we got that. I'm going to make this window a little bit smaller just in case the bottom is getting cut off in the video.
Yeah, and one way to check that the command has run successfully is our first command was change directory, and as you'll see in the prompt that William has, it has changed from sentiment to AC IMDb.
And then if I do a listing of the directories, we can see we have that movie data folder, which currently has nothing in it. All right, so let's go back to the article. All right, so now this is some more just command line bash foo, as we call it, of just taking this data and saying, okay, split this data into training and testing folder, or okay, so it's concatenating each review into one text file to make it easier to read in later.
Yeah, it's just creating one for positive and negative. It's just nested for loops. Which it's doing this.
Okay. All right, so we'll just copy and paste that whole business, and it's gonna take a little while to do it. Hopefully not too long. For split in train / test. Oh, okay. So the folder was already set up with a folder named train, which we see up here, and a second folder named test.
Yeah, and I mean it's basically what it's doing is it's splitting out all the movie reviews into test and train. So there are 25,000 that are just going to be for training and validating. And then the other 25,000 is just for testing.
Okay.
And even within those 25,000, it would be 12,500 positive reviews and 12,500 negative reviews.
Okay.
And both for testing and training.
Excellent. All right. So while that's still going, and we can pop this out a little bit so we can see it.
And one more thing. So the first 12,500 I think are the positive reviews, and the lower 12,500 would be the negative reviews. That's something that we would find useful later on in the article.
Oh, okay. Excellent. Oh, and we're done. All right. Cool. So that's nice. As we've talked about earlier, it's really important to have a fairly even balance of whatever classes you're trying to train. Because if you had, 95% of reviews were always positive, then any algorithm we would train would just assume that positive was the right answer because that would work 95% of the time.
Yeah.
All right, so now we can start this, but let's take a quick look and make sure we don't have any libraries that aren't in our Anaconda environment that we need to put in here. Okay, I don't think we have RE, which is a regular expression library. So let's just double check. Okay, we have scikit-learn. All right, I think it's just that RE that we don't have. So let's come back in here, and if you have the environment from the first video that we made, then you should be able to load that environment. On Chiha, we load that by first loading the Anaconda module. So module load Anaconda 3. On your home computer, you would just start up Anaconda, and then we do source activate NBOTW, standing for Notebook of the Week, and that'll get us in our environment for this particular the Data Science Club. So let's look up the appropriate way to install that library. So we do conda install RE is what we're going to search in Google, and here it comes up as one of the first things. All right. I'm glad I looked it up. A lot of times you can just say conda install and then the name of the library, but sometimes the name that you use in Python is different than the name that's actually in here. So RE is what you import in Python, but the name of the package that you install is regex. Again, standing for regular expressions. All right, so we'll just copy and paste that over here, and that should go pretty quickly.
Yeah, hopefully that's not a big install. And Conda generally does a very good job of all the dependencies of. That was something that we noticed a couple of weeks back with R, where we had to manually go and reinstall a bunch of libraries and dependencies.
Yeah, so it really is one of the beauties of Anaconda, is just taking care of all of those dependencies for you and doing it in a nice way so you don't have to think about it. All right, so yes, we do want to install it. It's nice. This apparently doesn't depend on anything else. Yeah. It doesn't have anything else depending on it. So it's going to be a fairly small install. All right. So now we have that. So now we're going to go back up and we're going to start running Python. So what we're going to do is we're going to start up a Jupyter Notebook. If you have Anaconda at home, then you can start up Jupyter Notebooks from that, or however you like to do it. Since we're using the UAB Chiha resource, we're going to come in through rc.uab.edu. We're going to go to Interactive Apps and click on Jupyter Notebook. All right. And let me make this bigger. All right. So now we're here, we're going to request the resources to run a Jupyter Notebook. So we're going to load our appropriate modules. We're going to say which directory we want to go to. So this is going to start our notebook up in the data user WS Monroe RC-DSC folder. I would recommend that you change this to your Blazor ID if you're on Chiha. If you have it on mine, it's not going to work. And 2 hours should be plenty. And we're going to run it on Pascal nodes. I don't think we're going to use the GPU today, but that's what we run for the Data Science Club generally, because sometimes we do have algorithms that need the GPUs to run efficiently. So we're going to launch that. All right, let's just refresh. You can see down here I was playing around with RStudio. I'm making some weird visualizations, and R is really good at that. All right. There we go. All right, so now our Jupyter Notebook is connected, and we can start that up. All right, so let's go into our sentiment folder and ECLIMDB, and we're gonna create a new Python notebook using this conda environment. All right, and we'll call this sentiment analysis part 1, because that's the name of the article. And we can start putting things in here. All right, so we're gonna go just copy and paste this. Let's see what this does.
Alright, so this doesn't have the path, need to give it the...
Yeah, so this doesn't have the appropriate
And we
path.
have
I think we're already in the same folder, so we just need to go here.
Yeah.
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 Alright. Alright, so previously we've used pandas to read in our text files. Here, this is just using native Python commands to read in the text files.
Yeah.
And so, you know, there's more than one way to do almost anything.
Yeah, so this is basically just reading the entire file into 2 different variables. So because we are using a Python script, so we need those files in these variables so that we can actually manipulate them and work on them.
Yeah. So now we have 2 things. We have reviews train and reviews test. So this data set is nice. It's already split into a training and testing data set. As we've mentioned in other videos, it's really important to have a testing data set that your algorithms that you're training don't see while you're training,
Yeah.
to make sure that you're not just fooling yourself into thinking that you have a good fit when maybe it's overfitting on particular data.
Yeah, and that should generally be different from your validation data set. So validation is something that you work on your training. In your training data set, you can divide it up into smaller train and validation data set. But yeah, your testing, where you are eventually going to be running, that should be completely separate. It should not see your script at all. It should just generally see the model that's finally generated.
Yeah. Yeah, and that's exactly right. So let's look at one of these reviews. All right. So this is about a movie called Bromwell High. I've never heard of that before.
I haven't either.
Let's see.
Is it Titanic?
I think this must be the Titanic. Okay, yeah, Rose, Gilbert Grape. I guess Leonardo DiCaprio.
That was a good guess.
Yeah, that was a good guess. What's your favorite number?
I don't know, 150?
Okay. Let's see.
Right to die. I don't know.
Right to die. I have no idea what that is. Let's go really high since we have theoretically 25,000. We'll go to 24,000.
Yeah. Unbotched and... So this is one of the bad reviews.
Yeah.
So anything about 12,500 would be bad review.
Oh, okay. All right. So if we go to 13,000.
He really wasted his money.
Yeah, he really did. He was not happy. Apparently, one way of telling whether or not it's a bad review is just how long it is.
Yeah. Angry people are really trying to take out their frustration in the reviews.
Yep. All right. Oh, this is about snakes on a plane, I think. Anyway. Let's go here. All right. So what we notice is that when we see the reviews initially, they have all these special characters, punctuation, things like that. The computer doesn't understand words. It also doesn't understand spaces and things. And so What we're going to do is we're going to use that regular expression library to clean out all of the special characters. So we're just left with the text. So that's what this block of code does. So we're gonna give that a whirl and see if that works. And then what we can do is, so you see these breaks, we'll actually look at we can look at this same review after we clean it and make sure that that's gone.
Yeah, I mean, basically the computer doesn't have. So, like, for instance, I was about to point, but I'm pretty sure you guys cannot see it, but you can see the arrow.
Use the mouse, yeah.
Yeah, so if you guys see this, it kind of makes sense to us when we see it, but computer doesn't care that you have 4 dots in between it. It's just going to take it as a continuation of a sentence. So those are some of the things that we are going to be replacing over here. Any dots, any kind of punctuation, those break things, we are just going to remove, and it's just going to become texts.
Yep. All right, so let's check that that's true, and we'll do reviews.
What was the number for this one?
Train clean, I think it was just
13,000.
13,000. All right. So these single quotes are something that Python is adding just to tell us that this is indeed a string. But you notice not only is there no punctuation, there's also no capital letters anymore.
Yeah, which is good. I mean, angry people put a lot of uppercase text.
Yeah.
Which computer doesn't need. So.
Yeah, and it, if you're really excited, you use 5 exclamation points. Maybe if you're really angry, you use 5 exclamation points. It's not necessarily helpful. Could be, but for these purposes, we're not using them. And so we're gonna.
Alright, so now our data is clean. There are some better methods. This is the most basic method, and I think it does a pretty decent job of cleaning up our reviews.
Yep. All right, so vectorization. All right, so this is a method of basically extracting numbers for these reviews, because again, the computer doesn't understand the words, so we have to give it some metric for what's going on with these reviews.
Yeah, I mean, it's mostly going to be very similar to one-hot encoding, and if you guys have been following our tutorials, it was very early in one of our YouTube videos where we actually put in a one-hot encoding. I think it was for the house dataset.
Yeah, I believe it was.
I don't remember. Yeah, I don't remember which thing it was for, but yeah, we did use one-hot encoding. So what it's basically going to do is it's going to take all the words in all the reviews and make a column out of all of them. And then it's going to assign 0 or 1 based on if that word was there in that review.
Oh, okay.
So basically, if I in my review it's A, B, C, D, and William's review is C, D, E, F. Then what it's going to do is it's going to take all the words like A, B, C, D, E, F as different columns. But when it's talking about mine, it will just put 1 in A, B, C, D and 0 in E and F.
And then what this does is this takes that glossary or index of all the words in all of the reviews, and then just puts a count of how many times that word was used in a specific review.
Yeah. And so that's, like they mentioned in the end, this is also known as one-hot encoding. The last line.
Yeah. Okay, cool. So what we can do is we can come to our notebook and we can run that code. So after this runs, we can look at that same review, right? But inside of this
X-test
form, I think it'll be under X, right?
Yeah.
So 13,000 under the training data set. All right, so now if we want to see how that horrified review of snakes on a plane looks like as a vectorized count or a one-hot encoded variable, we can come in here and just put 13,000. And yeah, so apparently there's 92,000 words.
Yeah, in total.
Total? All
Which
right.
is decent. I thought that there might be more.
I suppose people get really eloquent when they're angry. All right, so yeah, so if I print it out, we can see what's actually
What were the words? The only thing is we don't know. So one thing to see would be like the 41st word would be the first word in
the review.
Yeah. So O is the 41st word.
Yeah.
And then 698, 710. So yeah, I mean we don't have control over what was the hot encoding, and it's not showing you the exact word, but
yeah. But it does show us, and then apparently this uses many of the 92,000 words.
Yes.
In there. All right. So now we can come in here, or what else were you going to say about that?
Oh, we can actually check what is that zero and at least the first word. 41th word. We can just print that, right?
Oh, let's see. Inside of this
just the 41st column's title.
Oh, okay. Let's see, how do we do that?
So it should be X.
Because I think this is just a list, right? Or yeah, I'll give you the keyboard and let you do what you're thinking about. Yeah, I think because this is a...
How do we get the title? So we can see that O is used in all these reviews.
In all of those reviews, yeah. Yeah, so I think this is it a list or an array? Let's see. X dot D type. Yeah, so it's just an N64. So if this were a pandas data frame, it would retain the names in there, but it's not. So we can only tie it back if we do what Ravi was saying of actually maintain the dictionary outside of it. There might be a way in this. I bet this CV has it somewhere in there.
Right. Well, that's not something important right now.
Let's see, CV decode. Let's see. 41. No, that's not what it is.
All right,
we'll have to figure that out later. But there should be a way inside of this CV to decode what words correspond to which numbers. All right, so we're going to come down and we're going to keep on going. So we're going to build our classifier. So as we've seen previously, there's lots of different ways to build a classifier. Right now, for this purposes, we're just going to look at logistic regression. All right. Okay, so yeah, if you haven't done any data science before, but you've done statistics, you should recognize logistic regression because it's something that you do in statistics. So if data science is something that's scary to you, let this just kind of be a lesson that it shouldn't be because you're probably already doing it. Yeah. But this is really neat how, if I was just having a conversation and saying, okay, well, I'm going to classify movie reviews and whether or not they are positive or negative with logistic regression, my first thought would be, I don't really know how you classify, oh dear Lord, how on earth was any part of this film approved by anyone? It reeks of cheese, as, because that's not a number, so I don't know how to do that. But by using this count vectorizer, we've suddenly turned this into a metric that is numbers based, that we can use logistic regression on. And so we can go ahead and see that. All right, so we've imported logistic regression, and we have an accuracy score, and we're also doing train test split. So this is also nice. So not only do we have training and testing data, but again, inside of this, we're splitting our training data into training and test.
This was what I was mentioning earlier, that have the final testing data just completely separate. So this would be like validation data set and training data set over here.
Yeah.
But if you have short, small data set, then you don't have a choice to use the same data set for both training and testing.
Yeah.
But this one is a big enough range. And the first command that we are running over here, this target, this is where that initial way they have created the files is important, because the first 12,500 they are giving the value 1 because they were positive reviews. And the rest of it 0. You need to define a target, what each of those reviews mean. Otherwise, even a one-hot encoded matrix is not going to do anything if it doesn't know that finally if it's a good review.
Yeah, so we need that label.
Yeah.
Or, as you said, the target. Because we are doing supervised training. So we have to tell the logistic regression whether or not it was a positive or a negative review. So so the first 12,500 were positive, second with that. Now, I'm assuming, does train test split? I guess train test split automatically does some shuffling of the data as well.
Yeah, it does. There's generally we use a random
state just to make sure we're getting the same answer every time.
Yeah, but I'm pretty sure it still randomly chooses something.
Okay. All right. And then
so it
after this is saying, okay, so once you do the logistic regression, this is saying, all right, 0.01, 0.05, 0.25, 0.5, and 1. All right. So let's look up what that is doing. This must be the confidence.
Yeah.
Maybe? Let's look it up. So if we go to, we just search sklearn, logistic regression. All right, we can go to the documentation. And if we come down here, all right, so C is the inverse of regularization strength. It must be a positive float. So smaller values specify stronger regularization. All right, so it's a regularization thing. And 1 is the default. So, okay, so this is saying, all right, I'm going to specify, just to try different things, I'm going to specify different regularization coefficients.
Yeah, and whichever one gives me the highest accuracy.
That's the one that we'll end up keeping later, but that's what's going on here, is we're going to print out the regularization constant and then the accuracy for each one of those. All right, so let's run this. Let's see.
0.05 seems to be the best now.
Yeah, so 0.05 looks like it's the best. It looks like the regularization doesn't change a whole lot throughout this.
Yeah.
So the other thing that we could do just for fun is come in here and do, let's see, XG. Do we have XG boost on here?
Oh, no.
No, we don't.
I remember from our previous discussion.
Yeah.
We need to-
All right. So we'll do sklearn, and let's see, tree. All right. So we're gonna import random. Let's see. Let's look up which one we gotta use here. So we'll do sklearn random forest. Regression, or I guess it's a classifier, isn't it?
Yeah, we have the class second.
Yeah. All right. Oh, so it's ensemble. Ensemble. Import random forest classifier. Okay. And we could just pop in here. All right, let's just see if that'll work.
Oh, I don't know if that has the C.
It doesn't have the C.
Yeah, so we don't really.
So we don't need that.
Yeah, we can actually do it just outside of the for loop. Anyways. Oh, yeah, some of those would be fine.
Comment that out.
Alright.
Yeah, we'll just put one right there. We gotta make that a string. There we go.
And how much? So the one with 0.74.
Okay. So so it looks like in this case, logistic regression
Did a better
job than random forest did. So yeah, so that's pretty cool. It's always nice to try a couple of different models just to make sure that you're not seeing something really weird.
Yeah.
But that's helpful. So it looks like our logistic regression got similar as to what he got. All right, train the final model. All right, so we're gonna come back here and now that we've decided logistic regression with this regularization is the best, we're gonna retrain our model on our whole training data set. So you notice this isn't the train test split. Now that we've done our validation here, then we're going to train it on the whole data set and then test on the test data set that we didn't even see the first go around. And then we're going to come down here and we're going to, all right, so this, here we go, get feature names. That's what we should have done. So this is what we were talking about earlier. This count vectorization that we trained earlier can actually tell us which features based on the numbers that we give it. So we're going to come in here and say, okay, give us the feature names for all of the coefficients from the final model, and then just give us the best 5 and then the worst 5. And that's what we're going to do in this one here. So let's give that a whirl.
We should technically get the same result that they got.
That's it. Probably, since it's in the comments that we'll see. All right. All right, yeah. So we got the same. So if you have a positive review, then you most likely have one of these words. And if you had a negative review, then you most likely have one of these words. All right. makes sense.
Waste is very high on the list.
Which one? Oh, waste. Oh, interesting. Like this is a waste of time.
Yeah.
Yeah.
I can see excellent being the best positive word.
Yeah. Yeah. All right. So, so as we mentioned, this is just the beginning of natural language processing. If you're dealing with, trying to get information out of abstracts, Twitter feeds, movie reviews, natural language processing is the type of stuff that you're going to be doing. And the basic gist is it's really the same as everything else that we've been doing. The key difference is you have to do something to turn your words into something computable so that your machine learning algorithms can figure out the differences between the classes. And so I think we'll probably next time do this sentiment analysis Python part 2 so that we can check out some of those other ways of getting metrics out of the text and see if we can improve our accuracy.
Yeah, I mean, even, that would be really awesome, just learning new techniques and stuff. But even without that, we got almost 88% accuracy of what a review is, like whether it's a bad review or a good review. So that's not bad actually for the just very basic classifiers and very basic data cleaning. So
So today, let's think of an application. So today, if somebody came and asked you, "Hey, could you find out whether or not people feel good about like a company like Apple," then you could pull the every Twitter mention that mentions Apple and then run this algorithm on it, and you would be able to see whether or not with theoretically reasonable accuracy whether or not most of the tweets were positive or negative.
That's true.
So all right, well, until next time, thanks for joining us. Subscribe if you haven't done that already. And if you guys are on the UAB campus, feel free to drop by office hours. And if you're not, just leave us a comment. We're happy to try to answer questions and help where we can. So we will see you guys later.
All right.